These are solutions to Melham's Calculus 1, Chapter 4 exam. Okay, question 1. So the derivative is 4 minus 2x equals 0. That gives me x equals 2. So I've plugged in the two endpoints, which are 0 and 4, and also plug in 2. F of 0 is 2 plus 0 plus 0, which is 2. F of 2 is 2 plus 8 minus 4, which is 6. F of 4 is 2 plus 16 minus 16, which is 2. So absolute minimum, we have a tie, 0, 2, 4, 2. You should list them both. If there's a tie, you always list both of them. Absolute max is 2, 6. Number 2, f prime is 3x squared plus 6x, which factors into 3x times x plus 2. F double prime is 6x plus 6. Set y prime equal to 0. That gives me 0 and negative 2. F of 0 comes out to be 0. F of negative 2 is 4. I have 0, 0, and negative 2, 4. Sine chart, I plugged in negative 3, negative 1, and 1. Okay, negative times negative is positive. Negative times positive is negative. Positive times positive is positive. Increasing, decreasing, increasing. F is increasing from negative infinity to negative 2, union 0 to infinity. F is decreasing from negative 2 to 0. That means negative 2, 4 is a max, and 0, 0 is a min. F double prime equals 0 gives me x is negative 1. Plug in negative 1, you get negative 1 plus 3, which is 2. Sine chart for the second derivative. Plug in something over here like negative 2. This is negative. Plug in 0, it's positive. So concave down from negative infinity to negative 1. Concave up from 1 to infinity. Inflection point at negative 1, 2. Number 3, always decreasing. Concave down, concave up, goes with the origin inflection point. Number 4, we get 0 over 0, do L'Hopital's rule. E to the x minus 1 over 2x, still 0 over 0, L'Hopital's rule again. Limit x approaches 0, e to the x over 2, plug in 0, you get 1/2. Number 5, limit as x approaches 0 from the right of x to the x. Let y equal x to the x, which means I'm finding the limit as x approaches 0 from the right of y. Ln y is x ln x, which is ln x divided by 1 over x. Okay, as x approaches 0 from the right, okay, I get infinity over infinity. So I do L'Hopital's rule. Treat this as x in negative 1. So that's infinity over infinity. So differentiate the top, differentiate the bottom. Limit at x approaches 0 from the right of 1 over x divided by negative x at negative 2. Take out the negative over there. X at a negative 2 comes upstairs as x squared over x. Negative limit as x approaches 0 from the right of x, which is 0. So limit as x approaches 0 from the right of ln y is equal to 0. Exponentiate both sides. The limit as x approaches 0 from the right of y is equal to 1. Number 6, f of x equals x over x minus 1. The derivative is using the quotient rule. Bottom times the derivative of the top, 1. Minus the top times the derivative of the bottom, 1. Over x minus 1 squared. That's negative 1 over x minus 1 squared. That's always less than 0. So the function is decreasing wherever it's defined, not defined at 1. So you can't say from negative infinity to infinity. The best we can say is f is decreasing from negative infinity to 1, union 1 to infinity, increasing nowhere, therefore no max and min. Okay, rewrite f prime as negative x minus 1 to the negative 2. Second derivative is 2 times x minus 1 to the negative third power. There should be a negative here, which comes out to be 2 over x minus 1 cubed. Okay, so sine chart, plug in the, lay down the 1, plug in 0, negative, plug in 2, positive. So the function is concave down from negative infinity to 1, concave up from 1 to infinity. You do not have an inflection point. There is a change in concavity, but you don't have a point. So if you don't have a point, you don't have an inflection point. Number 7, here's the line, here's the origin. The square of the distance from the origin to a point on the line is x minus 0 squared plus y minus 0 squared, which is x squared plus y squared. Y is given to be 2x plus 5 squared. That's what I want to minimize. F prime is 2x plus 2 times 2x plus 5 times 2. 2 times 2 is 4. Distribute 10x plus 20. Second derivative is 10. That's greater than 0, which means concave up, which means we have a minimum. Am I looking for a minimum? Yes. So set f prime of x equal to 0. 10x plus 20 equals 0. X is -2. Plug back into y equals 2x plus 5 and y is 1. So the ordered pair is -2, 1. Finally, number 8, x equals radical 7. X squared is 7. So f of x is x squared minus 7. X squared minus 7 equals 0. The derivative is 2x. Okay, so assuming you have a calculator that has the answer, if you don't have the answer button, you can still do it the long way. So first guess is say 3. It's a good approximation. So you put 3 in a calculator and then you go answer minus answer squared minus 7 divided by 2 answer. Okay, here are some successive iterations. X2 is 2.67. X3 was 2.645, which happens to be the same as X4. I should really put X4 here, but it came out to be the same thing. Okay, so round it to 2 decimal places like it says 2.65. Right, so these are solutions to Melham's Calc 1 exam number 4.